fast electrons. Okay, if we go with fast electrons, 10 to the power 6 meter per second is the velocity of electrons. So 6.6 approximately you will take it as 6, and 6 3 2s are 6, 3 3s are 9, 2 by 3 is 0.666. So it is 0.7 approximately. Okay, 0.7 is the value of this particular solid, and 10 to the power of minus 31 plus 6 is 10 to the power of minus 25. Okay, 10 to the power of minus 25. If you take it out of upper side, it becomes 10 to the power plus 25. 34 minus 34 plus 25 is 9 and 0. Right? 10 to the power of minus 9. 10 to the power of minus 9. Fine. 0.7 into 10 to the power of minus 9. Fine. So it is 0.7 into 10 to the power of minus 9 can be written as 70 into 10 to the power of minus 10 meters. So it means approximately 70 angstroms. See, it is very much detectable because we have X-rays of this order. X-rays range is from 1 angstrom to 100 angstrom. Such X-rays are there. You can measure them. Here, this electron's wavelength is approximately 70 angstrom, which is also measurable. Means particle nature, the wave nature for a particle like electron can be understood, can be detected, can be comprehended, can be measured. Okay. So because as X-rays are measured, X-ray wavelengths are measured, X-rays can be used for other purposes. You can make it run, you can make it scatter, you can make it diffract, you can make it collide with certain other objects. Like in the same way, you can use wherever you are using X-rays, you can use very well electrons as waves, not as particles. Electrons as waves, because electrons have specific wavelength which is measurable. You cannot do it with a tennis ball, you cannot do it with a sand particle of higher mass. You can do it with very small particles like electrons. Okay, that's why this formula gives noticeable results only with smaller masses. As and when mass becomes small, lambda will become big. As and when mass becomes small, lambda becomes big. Mass becomes big, lambda becomes small, highly immeasurable. Okay. That is the idea here. So this is the hypothesis of De Broglie, and using this hypothesis, we have several variations of this formula. Several variations of this formula we will discuss now. Okay, what are those variations? Lambda is equal to h by 2. This is the basic formula. H by p I will write. Okay, lambda is equal to h by p. What is p? P is the momentum. Momentum of any particle, not only light, momentum of any particle, h by mv. Okay, this is the general expression. But momentum can be written as root of 2me, if you remember, ek. What is, how do you get this equation? Because from the equation mv square by 2 is equal to kinetic energy. What is mv square by 2? It is kinetic energy. mv square is equal to 2ek, right? 2ek. And mv square, let's multiply both sides by m. Okay, let's multiply both sides by m. This becomes m square v square is equal to 2me. Okay, 2me. M square v square is p square. P square is equal to 2me. It means p is equal to root of 2me. So this expression connects kinetic energy of a particle with its momentum. Okay, if there is a ball which is having a momentum called p and its kinetic energy is ek, then the mass of the ball, kinetic energy of the ball multiplied by 2 inside the square root will directly give you the momentum of that particular particle. And you can substitute in the place of momentum its kinetic energy if you know it. Lambda is equal to h divided by root of 2me is another expression we can use extensively in our NEET classes. Okay, h by root 2me. Fine. Then wherever kinetic energy is used, in the previous discussion of photoelectric effect, how do you get the kinetic energy for particles having charges? See, these are negative charges. From negative plate, electrons are released towards the positive plate. They are highly attracted, and now we can say they have kinetic energy. Electrons, if you make this more strong, if you apply more potential difference, electrons will rush with more kinetic energy. Means the voltage given and the kinetic energy of electrons have a relationship. What is that relationship? That is Ek is equal to EV, right? The charge of electron into voltage, energy is EV, no? That's E into V. In the place of Ek, you can put EV here. That's why lambda is equal to H divided by root of 2m EV, right? Root 2m EV, if you know the voltage, potential difference with which the particles are moving. Suppose you have a proton, okay, instead of electron, you have a proton, which is a big particle. It is attracted towards electron. You have applied 10 volt potential difference. In 10 volt potential difference, protons will come with higher velocity. If you make it 20 volt, protons will come with even higher velocity. So, by increasing its velocity, you are increasing its kinetic energy by increasing the potential difference. So, how do you calculate the kinetic energy? Ek is equal to charge of the proton. Then the equation will become charge of the proton. Ek is equal to charge of the proton into V. It becomes Q into V for proton, for other particles which are having charges. But for electron, it becomes EV. Okay, 2m EV. H by root of 2m EV. This is another very important equation for NEET questions. Okay, we will simplify this for electron because H is a constant we know already. M is a constant we know already because it is all about electrons. Mass of the electron we know, charge of the electron we know, H is a constant we know, and it becomes 6.634 into 10 to the power of minus 34 divided by root of 2 into 9.1 into 10 to the power of minus 31 into electrons 1.6 into 10 to the power of minus 19 into V. We don't know. Because voltage can be anything. You can put 1 volt, 2 volt, 3 volt, 100 volt, no problem. V is the only thing you don't know. Then, after simplification, it becomes 12.27 into 10 to the power of minus 10 whole divided by root V because V remains there. Instead of V, if you calculate everything whichever to be known about electrons you know everything except this voltage because voltage is not in your hands. You can give it anything you want. It is variable. These three things are not variables. Not variable, not variable, not variable, not variable. That's why if you put the values there, then the same formula will take this shape. Same formula will take this shape for electron. For electron. Not for any particle. It is for electron only. Okay, 12.27 into 10 to the power minus 10. 10 to the power minus 10 is there. Angstrom is there. Okay, remember it is angstrom. Or you can also take it as angstrom. It is measured in angstrom. Lambda is to be measured in angstrom. 12.27 divided by root V. If they ask what is the wavelength of an electron moving under the potential difference of 4 volts, if they ask you 4 volts, 12.27 divided by root 4. Just put root 4. Simple enough. Root 4 is 2. Divide the entire thing by 2. So 2 divided by 2 means 6.13. 6.13 angstrom is the wavelength of the electron. Okay. Simply you have to know the voltage only. Simply put the voltage, remaining everything will be easy. So this is a shortcut you should know. Okay. So I think we will conclude here up to this point. De Broglie has given this expression for calculating the wavelength of any material particle which is having mass m and velocity v, and using that expression in the place of mv, we can put the root of 2me, where E is the energy of particle, kinetic energy of the particle, and kinetic energy of the particle can be replaced by ev, and h by root 2m ev can be written. This is also another expression for De Broglie's wavelength, and if you simplify it for the electron, it becomes 12.27 into angstrom, 10 to the power of minus 10 by root v. Okay. So tomorrow we will discuss 2 experiments, one experiment, and we will directly go to NEET questions. Thank you. Good morning. Let's discuss today the NEET aspects of dual nature of matter and radiation. The remaining part, that is the questions based upon De Broglie hypothesis. Okay, right. So before that, I think something is left. We have discussed photoelectric effect, the concept of photon, the de Broglie hypothesis, the equations of de Broglie hypothesis. That is, de Broglie proposed that h by mv will be the wavelength of a material particle. Means if electron is a material particle, it is not a particle when it is moving. It will be associated with the wavelength of its own according to de Broglie. And if a tennis ball is moving with a certain mass m and moving with the velocity v, electron has a mass m and it is moving with the velocity v, then its wavelength, it is supposed to be a wave. It can be picturized as a wave, and its wavelength can be given by h by mv according to de Broglie. And any mass particle of mass m moving with a certain velocity v can have a wavelength lambda, which is given by h by mv of that particular particle, where m is the mass of the particle and v is the velocity of the particle. This much we have understood. And later we have seen that lambda is equal to h by root of 2me, that is the formula, modified formula, whereas in the place of mv means momentum. In the place of momentum, we can write square root of 2 times mass of the body and kinetic energy of the body. And you can replace kinetic energy as well by another equation, 2m E into V in the case of electrons, Q into V in case of any charged particle like proton, alpha particle, like that. Okay. So H by 2m Q into V, that is another formula. For electron, this becomes simply H by root of 2m eV, because for electron charge also is known, mass is also known, H is also known. So that comes out to be 12.27 angstrom divided by root of V. Okay. So this is the formula we have obtained. All these formulae are very important. You must keep those formulae in mind to understand, to calculate the de Broglie wavelength. In NEET examination, either one question will be there from photoelectric effect or from the de Broglie hypothesis. That's why we are taking an extensive time. I took an extensive time on dual nature of matter and as well as on the de Broglie hypothesis, and all the questions we have solved. Because one question will be compulsorily asked every year in the NEET examination or otherwise in the JEE mains or advanced, whatever it is. Okay, that's why it's such an important chapter. You cannot neglect it. Yes. After this, characteristics of photon. We have to dwell upon characteristics of photon. What is a photon? Photon is an energy particle whose energy is given by h nu or hc by lambda. That is the wavelength of the photon. A photon is a pocket of energy which is not to be thought as a material particle, whose rest mass is 0 and whose momentum is not to be taken as mc. It should not be taken as mc. For theoretical reference, we calculate it as mc, but we will write it as E by C, because energy is equal to Pc. What is P? P is mc into C. It is nothing but mc square. So according to this formula, you can write momentum of the photon must be taken as energy carried by the electron divided by the velocity of light. Means the momentum of a photon is not calculated by the mass of the particle and velocity of the particle, but it is calculated by the energy content of the photon, that is nothing but E by C. Okay, this is how we understand momentum for the photon, means the light particle, which is proposed by Einstein himself. Okay, all these things we must know. And in the last bit, we will discuss about Davison and Germer experiment. I have left that particular aspect. We were about to discuss that. Davison and Germer experiment to prove that matter waves did exist. De Broglie just told that matter waves like electrons are particles, they are mass particles. They are to be treated as matter waves. How do you prove that they are matter waves? How do you prove them that they have a wavelength and it can be calculated? So for that, Davison and Germer have conducted an experiment. Davison-Germer experiment. What is the purpose of this experiment? The purpose of this experiment is to prove that matter waves do exist. Okay, and there is an experimental arrangement for this particular experiment. They have used X-ray diffraction technique, X-ray diffraction across crystals. X-ray diffraction across crystals. To understand this particular experiment, you should know what do you mean by diffraction in crystals. Diffraction, I will simply tell you, if there are two balls here, spheres, and if you allow a wave to pass through these spheres, then these waves will not pass straight around the obstacles, around the edges of the obstacle. They simply bend. These waves simply bend across the edges of the obstacle. Means if there is a slit, okay, slit means a small hole, and if you pour light into it, when light falls over these slits, light will not go straight across the edges. It will have a little bend across its ends. This phenomenon is known as diffraction, and the angle of bending of diffraction theta is directly proportional to the wavelength of the light. So we use the particular formula n lambda is equal, d is equal to n lambda. D is equal to n lambda. This is what we use there, and d sin theta is equal to n lambda. More particularly, d sin theta is equal to n lambda, where theta is the angle of diffraction, d is the distance of the slit, means how small is the aperture, how small is the slit, and theta is the angle of diffraction. N is a number, n is equal to 0, 1, 2, 3, 4, 5, 6, like that, and n is that corresponds to order of diffraction, and lambda is the wavelength we use. Okay, so it says that theta has something to do with lambda. If lambda changes, then the angle of bending changes. Got the idea? Yes. So, if this is a wave, then a wave can bend across the edges of an obstacle. Wave can bend across the edges of an obstacle, and the bending angle is directly proportional to the wavelength of the light used. This is the rough idea behind diffraction across crystals. Why crystals? Because crystals have atoms. If you make X-rays to fall on atoms from the edges, between two atoms there will be a bond length. There is a gap between two atoms. So between the gap, within that gap, whenever X-rays follow, they just diffract, and the diffracted X-rays are obtained on the screen. They will give you a diffraction pattern. Looking at the diffraction pattern, they will determine how much is the wavelength of the X-ray. Actually, X-ray's wavelength is 1 angstrom to 100 angstrom. X-ray's wavelength is 1 angstrom to 100 angstrom. So, which is very close to the atomic gap between the atoms, because the atoms are separated within 5 angstrom, 10 angstrom, like that. Okay, the atomic separation is almost equal to the wavelength of the light we are using. X-ray is the best suited for that, because X-ray wavelength is suitable to the atomic distance. Okay, that's why we use X-ray diffraction technique for crystals. So Davison-Germer, they have used X-ray diffraction technique, but instead of X-ray, they have used electron beam. They have used what? Electron beam. Okay. See, now between these two atoms, electrons pass through. Okay, electrons pass through. If a wave could generate a diffraction pattern, then if electron is a wave, then electron must also produce a diffraction pattern, right? Because the diffraction pattern is the signature of wave property. If you want to prove somebody is a wave, you should prove that somebody will produce a diffraction pattern. If somebody produces a diffraction pattern, then it is 100% sure that that particular thing is a wave. if electron beam could produce diffraction pattern, then 100% electron beams are waves. This was the idea of Davis and Germer, and Davis and Germer have used this particular technique. Let's write the diagram of Davis and Germer experiment. Okay. Because the diagram of Davis and Germer experiment they used to ask, right? And what happened in that experiment also very important. Yes. 1 minute.